welcome back. We were talking about the nonlinear devices, and when we give multiple inputs to the nonlinear devices, what is the effect of that. We have taken two inputs, omega 1 and omega 2, with the same amplitude V, and then we have tried to plot that this is omega 1 with some modulation and this is omega 2 with some modulation. This is frequency and this is amplitude, of course. And then what really happens, I was trying to explain that the difference between omega 1 and omega 2 is this, that is delta omega. So, your omega 2 minus omega 1 will fall somewhere here. Depending on the transponder bandwidth, it may fall within the transponder bandwidth. That is one problem. When they are modulated, there are other frequency components coming. Let us assume that this frequency component and this frequency component. So, they are smaller than delta omega, whatever we have taken, which is omega 1 omega 2 minus omega 1. They are smaller than this. So, their product will be much closer. It is possible that it may fall here, this and this product may fall within the filter bandwidth of one of the fundamentals, then it is a problem. So, therefore, these intermodulation products can create a problem, and intermodulation product comes because of the nonlinearity. And let us see there some more definition of the that nonlinearity. Let us say, let us try to plot this again, that amplifier characteristics, which is P input in dBm and P out in dBm. Now, initially the fundamental goes linearly and then it deviates from linearity. So, there is a 1 dB compression point. Let us extend this linearity. This is that let us say the one of the component, that is P omega 1, the slope is 1 in dB. The third order intermod, one of the third order, let us say let us define that 1 dB compression point. So, this was supposed to be our IP 1 dB and this is OP 1 dB. Now, the third order term, since it is a cube term, it is a slope of 3. So, it when it starts comes out of the noise, basic noise level, it comes out, it goes up with a much higher slope. So, I am extending the linear part of that, which is P, let us say 2 omega 1 minus omega 2 curve, power curve, which is virtually meeting at some point with that fundamental term. Now, this point is defined as intercept point, and this is, since it is taken from the third order, so it is called third order intercept point. From the input side, we can define this as input intercept point third order, and this side we can define as output intercept point third order, 3 for third order. This input and output we are defining because the output in some cases, like in amplifier, that output intercept point third order is more than input intercept point. In mixer, that input intercept point third order is more than output intercept point. So, based on whichever is higher, the device manufacturer they specify that intercept point. So, we have to just refer that which side, and then output is always the gain times the input. It is on the linear p omega 1 axis. So, this is another definition that we have talked about, two definition, that is 1 dB compression point in referred to input and or output. Similarly, third order intercept point referred to input or output. So, by defining the 1 dB compression point and third order intercept point and the gain of the amplifier, device manufacturers they more or less say that this is the type of nonlinearity you are going to face. They always may not give you the full curve, but from these two we can derive many things. So, let us see that how it can be utilized. Let us try to see that how it can be expressed in terms of Taylor coefficient. So, IP3, that input that is intercept point 3, it may be output or input, whichever you can take, can be expressed like in Taylor coefficient. Let us see, p omega 1 is the output power of desired signal at omega 1. So, p omega 1 is half of A1 square V square, its power. So, A1 square V square. Similarly, p 2 omega 1 minus omega 2 is the output power of third order intercept point at frequency 2 omega 1 minus omega 2. So, p 2 omega 1 minus omega 2 can be expressed in the third order term 3/4 A3b cube square, which is 9 by 32 A3 square b to the power 6. So, it is now is coming in terms of Taylor series coefficient. Now, we have seen in this is the intercept point where that p omega 1 continuation of that and p 2 omega 1 minus omega 2 continuation of that meets. So, if we take the extension of this, this is the point we can equate these two and find out the relation of that. So, that if we define that VIP is voltage at intercept point, then p omega 1 minus equal to p 2 omega 1 minus omega 2 at intercept point can be expressed as half of A1 square VIP square is equal to 9 by 32 of A3 square VIP to the power 6, because individually we have seen in terms of Taylor coefficient. So, from that we can express VIP as 4 A1 by 3 A3 square root of that to the power half. This VIP can be found out from this expression. Now, since OIP3 is equal to linear extension, linear response of p omega 1, we can put OIP3, we can define p omega 1 at V is equal to VIP, that will be equal to half of A1 VIP square, and this VIP value if you put here, then you will get 2 by 3 A1 cube by A3. So, now OIP3 can be expressed in terms of Taylor coefficient A1 and A3. OIP3 is equal to 2 by 3 A1 cube by A3. Let us look at it that when two nonlinear devices are cascaded, they put one after another, then what happens to our this OIP3, and what should be the equivalent of the third order intercept point. So, let us take two devices instead of stating right now whether it is amplifier, mixer or what device, simply we will put some gain. So, the first device gain is G1 and its OIP3, since it is the first device I put 1 prime of that. And there is the input to this. This output will have certain voltage, we will call V prime, will have some power P prime, and this is going to the second stage which has a gain G2. This G and G1 and G2 are power gains, OYP3 double prime I put for the second stage. So, output of that will be V double prime, in terms of power it will be P double prime. Now, this whole thing could be said in terms of one single block, which is the cascaded effect, where G1 and G2 multiplied, that is the gain G, and it has a OIP3. So, this OIP3 in terms of the individual OIP3 of the individual stages and their gains, we will try to express that. Okay. So, we can write that P 2 omega 1 minus omega 2 prime is 9 by 32, we have come across this, A3 cube to the power V 6. Now, this whole thing can be rewritten so that we get a relation between P 2 omega 1 minus omega 2 in terms of P omega 1 and OIP 3. I will write that relation. If I write it this way, 1/8 A1 to the power 6 B to the power 6 by 4 by 9 A1 to the power 6 A3 square. Now, you can see, you can cross check this and you will get back to 9 by 32. 9 by 9 goes up, 8 into 4 32. Similarly, A6 A1 to the power 6 gets cancelled, and A3 square B 6 B to the power 6 remains. But this means is P omega 1 cube by OIP 3 prime square. So, I have a relation P 2 omega 1 minus omega 2 prime is P omega 1 cube and OIP 3 prime as square. So, the first stage output I can write in terms of voltage, if we write that that is V prime for the intermodulation product, that component, the voltage of the distortion, that is distortion voltage, is the power P 2 omega 1 minus omega 2 prime into Z naught to the power half. is voltage, and if I assume that Z naught is the impedance for that. So, this is equal to P omega 1 prime cube into Z naught by O I P 3 prime square to the power half, and this again to the power half. P 2 omega 1 minus omega 2 I replaced by this term, which is from here. Now, if we try to solve this, this is now the V prime of that particular third order intermod distortion voltage. Now, if we go to the second stage output, this voltage will be multiplied by the gain, and this is of course power gain. So, it will be root over of that, and the distortion added by this second device, the distortion voltage that is added by the second device. So, we can write the whole thing like this, that is V 2 omega 1 minus omega 2 double prime is equal to the gain times P omega 1 cube Z naught, and since the whole thing is the power gain, so gain has gone inside, so this is to the power half, and that half has reduced OIP 3 prime, square was there, so that root over gets cancelled. This, the first stage gets amplified, and the second stage distortion is P omega 1 double prime whole cube into Z naught by OIP 3 double prime. So, the first stage output is multiplied with the gain of the second stage, and the second stage distortion is added to this voltage. Now, when we go from this voltage, we can do some sort of a readjustment, that we, because it is a cube here, to make this and this term equal, if I make this G 2 in terms of cube, then G into P omega 1 prime is equal to P omega 1 double prime. So, to make that, I multiplied by G 2 in numerator and denominator. So, since it is inside the root over, so it becomes G 2 cube P omega 1 prime cube, then Z naught divided by this is to the power half, and G 2 into OIP 3 prime plus P omega 1 double prime whole cube into Z naught OIP 3 double prime, and this is the square root of that. Now, for P omega 1 double prime is G 2 in P omega 1 prime. So, this part is replaced, and this one comes out to be, or I can write the whole thing, it comes out to be P omega 1 double prime whole cube into Z naught to the power half multiplied by, since numerator is taken out, so it will be 1 by G 2 OIP 3 OIP 3 prime plus 1 by OIP 3 double prime. So, this is the voltage part is coming. Now, if I try to convert into power, so it is P 2 omega 1 minus omega 2 double prime is the voltage 2 omega 1 minus omega 2 double prime square by Z naught. So, by replacing this voltage V 2 omega 1 minus omega 2 as this term here and square of that, then it comes out to be P omega 1 double prime cube into 1 by G2 into OIP3 prime plus 1 by OIP3 double prime to the power square of that, and that Z naught gets cancelled. There was a Z naught there, and that Z naught gets cancelled. Now, if we define that this one is only inside this part, is our equal to our OIP3, which is the total that intercept point of the cascaded system, then I can write OIP3 is equal to 1 by G2 OIP3 prime plus 1 by OIP3 double prime minus 1. Then if I write this, then this term, the whole thing comes out to be P omega 1 double prime cube by OIP3 square, because the square term is there. This is, I can write it this way, the 1 by this is equal to this, that also. So, now I have a relation P 2 omega 1 minus omega 2 is equal to P omega 1 double prime cube, that is the second stage, omega 1 the fundamental thing cube, and OIP3 the whole thing, which is nothing but 1 by OIP3 cascaded system is 1 by G2, that is gain of the second stage, OIP3 of the first stage, plus 1 by OIP3 of the second stage, or you can put it inverse if this is put as a numerator. Now, this is in case of in case of coherent, and in case of non-coherent it can be calculated. It is a power addition, because if the two carriers are slightly away, then their the intermodes will be further away, and there due to randomness there won't be any correlation. So, therefore, it can be random and only powers can be added. Then in that case OIP3 double prime will become 1 by G2 square OIP3 prime square plus 1 by OIP3 double prime square, and to the power, that is like this, 1 by this is equal to root over of that. So, this is the expression, you can derive yourself. Now, with this I can give you some more information, that is that the manufacturers, how do they quantitatively measure and then specify. This is quantitative measurement. Intermode product. The term which is they use, carrier to third order intermode. It is defined as power of one of two main carriers divided by power next highest third order intermode. IM stands for intermode. I have used the term next highest, that is, we were showing till now both are equal amplitude, but it is possible that the carriers are non-equal amplitude. If these carriers are non-equal amplitude, say one carrier is larger than the other, their intermode products both sides may not be of the same size. They will be higher, one of them will be higher than the other. So, the ratio what is defined is the next higher order third order intermode, highest size of the third order intermode. This is the definition. So, this is a term which tells us about the two carriers in intermode noise, what it comes, and it's a carrier to third order intermode ratio. So, we can plot it C by 3 IM as we increase the input power, it will decrease. So, at the low input power, the intermode product is very low. So, this value will be high, whereas at high input the intermode will grow and then this will start falling. So, this is one way of representation. Since time is up, we will go for the next period. For the time being, thank you very much.